welcome everybody. So in the last video we wrote a method called copy. Our goal right now is to write a method called create collage, because when we last left it, we called canvas.createCollage. That didn't compile because the picture class did not have a method called create collage. And so we're now going to go into the picture class and we're going to add a method down here, public void create collage. And I'm going to build up to this. Again, our goal is to be able to create some cool collage. Our ultimate goal is to get this picture of this kind of fun garden. It's going to take us a little while to get there, but we'll get there. So just kind of housekeeping some at the beginning. Let's get the grid. So we're going to say pixel bracket 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 grid is equal to get pixels 2D. That's a grid of the pixels in this one. In this picture, which right now probably is the canvas, which is, remember, it's a big blank image. We're going to say picture flower is equal to new picture. And I'm going to write images plus, and there's an image called flower1.jpg. And by the way, I always do it like this when I create an image. I'm not quite sure why I do that. You could just kind of delete this and actually just have it say images slash. It just helps me remember that images is the folder and this is the name of the file, but actually you could write it as one big long string and it would be fine. So it turns out that the flower I gave you is a little bit too big, so we're going to scale it a little bit. We're going to say flower equals flower.scale, and it's going to be 0.4, 0.4. That makes it 40% as big in both the x direction and the y direction. And here's a fun line. We're going to create another 2D array called flower grid. And that's going to be flower, which is an image, or it is a picture, I should say, dot get pixels 2D. Notice up here I use get pixels 2D, and down here I use pixels 2D. Get pixels 2D is a method of the picture class. Here I'm actually using it on another picture, and here I'm using it on this particular picture, which is the canvas. And then just for a little bit of housekeeping, I'm going to do int flower rows is the number of rows in that image, which is, of course, will be flower grid dot length, our traditional kind of grab the number of rows in a 2D array. And int flower calls is equal to the same thing, flower grid bracket 0 dot length. You don't actually need to do that, but I've written this code a couple times and kind of preparing for this video, and it makes it a heck of a lot easier if you don't have to keep retyping those things over and over again. Okay, so I think we're ready to go here. And again, we're going to use our copy method that we just wrote to actually get it in the right place. So now we're going to basically loop through all of the rows in the original image, in the canvas's image, which is basically the grid. So int r equals 0, r is less than grid, not flower grid, but grid, dot length. And here's something a little bit interesting. We're going to say r plus equals flower rows. So what that will do is we're kind of going down how many rows there is in each flower. That's the height of the flower in pixels, rather than just by one. And if we can keep copying an image over and over again, that will get that in the right place. So then we're going to say copy. We wrote that method before. It takes an image. We want to copy the flower. So right now we're just going to say row r, and again that's going to go 0, and then it's going to go down not by 1 but by the height of the flower, and then 0. That's going to put it in the zeros column, in other words, flush left. Let's just compile that and make sure it all works right and see what it looks like. So let's hit compile. I think we're good there. Now this is not going to be a complete collage at all. We're going to be building up to that complete collage. But if I then, now I can run the picture tester, and I should get a bunch of flowers. There I do, kind of on the left-hand side, which is actually looking pretty good. Okay. What I'm going to do next is I'm going to also get the corresponding flowers over here. So actually we already are looping through the rows, so we actually don't need to make a whole nother for loop. But inside here, I just need to add one more copy command. So copy flower. It's still going to go in row R, but now where should it go so it is actually on the total right-hand side? That's going to be the number of columns, so the last column, so that's grid.length, minus flower calls, which actually, if you think about it, that's the width of the flower. If we left out this, it actually would draw the upper left-hand corner at the right edge, and we would see the flower off the edge of the screen. So that should give us an extra column of flowers. Let's see if that works right. So now if I can compile this, test collage. Okay, that's looking pretty good, huh? So now we're going to try to make a whole ring. So now I'm going to add this one and this one. That's going to take another for loop, looping through this time the columns. So now I'm going to do another for loop here, for int c equals 0. C is less than grid bracket 0 dot length. And again, I'm going to say c plus equals flower call. So I'm not going up by 1, I'm going up by essentially the width of a flower. And this is very similar. We'll add both of these. Copy the flower. In this case, it goes into row 0. Row 0? Yes. And then column C. All right, yeah, that's right. And then copy the flower into row. Okay, this is going to be the last row, so grid.length. It's the number of rows minus flower rows, comma C. Kind of compare how close this is to this, and I think that'll kind of make sense. So now we should be able to compile that. I think that should get us our complete ring of flowers. We're going to make one little improvement, but what did I do wrong? Is that, oh, it does work, okay. And now if I go in here and compile the picture tester, I'll drag this over here so you can see them all at once. Test collage. A nice little ring of flowers. Okay. Some of you, as I was typing that, were probably thinking, wait a second, how about the corners? And actually, you're right. I actually do draw these two columns and then these two rows. And so we are drawing a flower on top of itself in the corner. That's not really a problem, but I think if to really fix it, the first one we can actually offset it a little bit by just saying flower calls here. And then over here, I should write minus flower calls. What that does is it offsets it. It actually doesn't draw the first and last one in each column, in each kind of row, essentially. So now I'm actually not drawing them on top of each other. This will compile and work, just to show you it will, but it actually doesn't really have a big change. It actually just doesn't draw them in the corners, but you won't even notice that, to be honest. It should look exactly the same. Okay, so that's looking pretty good. We're getting closer here, but now we want to kind of think about this idea of concentric circles. So I'm going to introduce another variable here, way at the top of this method, called int ring counter. And this is essentially which ring I'm on. So I'm going to say ring 0, then ring 1, or then ring 2. I'm going to keep kind of going down and down and down until I basically can't fit any more rings. So you can think, when might you not be able to fit any more rings? That would be y. I'm going to say a while loop here. And, oh, sorry about that. When couldn't you like fit any more rings? That would be when ring counter times flower rows, as long as that is less than half the number of rows, because essentially that's how far you're going to be kind of going over. It's so many things you're going over. So if I put here grid.length divided by 2, what this is saying is, to think about it, when you're on ring 0, you're kind of offset by 1, then ring 1 you go in a little bit. Eventually, if you're going in so far that actually you're more than halfway over, then you're done. Now in this case, I'm actually going to do it this way, and ring counter times flower calls has to be less than grid bracket 0 dot length. We actually, in this particular case, don't need that second part because of the way our canvas is set up originally, but I'm trying to write this generically enough so that actually, no matter what size of the image or anything, it'll just work right. So if you want to be a little bit lazy, you could actually not put this bottom one, but I think it's a good idea to make it more generic. Then I'm wrapping all of this, things we did before, inside this while loop. So again, then down here I'm going to say ring counter, this is an important line, plus plus. So the idea is do exactly what we did here. We're going to modify the math up here in a second, add one to ring counter, and keep doing that while you can actually fit an entire ring in there. Let's go up here to the edit menu and do auto layout, and you can kind of see now that we have this crazy while loop, these for loop, and this actually takes us to the next counter, the next ring. Now if you think about it though, we haven't really done any math up here to change this, so this is actually not going to, this is going to draw the same circular ring on the outer edge. We want to have our rings go in a little bit. And again, our goal, you guys, is to get, just to show what we're doing, so we have this ring of purple flowers here, then this ring of red flowers here, then this ring of purple flowers here, and you want to keep going and over until eventually you can't fit another ring in there. Right? That's kind of what we're going with that. We're going to have to deal with the toggling of the flowers in a second, but but we're just going to get the math right now for these rings going around. Okay. So what I'm going to do is think about each ring is actually offset a little bit, right? This ring of purple flowers right here is actually offset 2 different, because we're on, this is ring 0, ring 1, ring 2, we're offset 2 kind of flower widths. So I'm going to make a variable inside here, and I'm going to say int offset row. And how far is each row offset? Well, you're offset by which ring you're on. So that's ring counter times flower rows. And then int offset column is equal to ring counter times flower. Oh, gee, I spelled flower wrong. Flower calls. And then if you want to think about it, so that's how far each ring is offset, both from the left and right, or the top and bottom. So see right here, this 0, well, this is actually not right. This should be offset row. And you want to stop your for loop a little bit short. So right here, I think I need minus offset row. Okay? And then down here where I have 0, well, that's not right. That should actually be how far you are from in the column direction. So this is offset call. And then right here, we want to go in. We've already subtracted one width of the flower, but now we want to subtract offset call. Okay? And then we're going to do a similar thing down here. Flower calls. See up here, we added offset row to the beginning and subtracted offset row to the end. We're going to do a similar thing. We're going to add offset call to the beginning and subtract offset call to the end. And then this 0 should be offset row. And then we want to subtract minus offset, oh no, set row. If I didn't make any typos, that should actually compile. Now, what it's doing here is going to be drawing this pattern, hopefully, but with this exact same flower. So it should just look like a grid of flowers if we do it right, although it's drawing them kind of in an interesting way. Let's see if this works. So we'll close this up. Close, we'll go over here. Compile this, test collage. And it actually, that actually is right, although they're not toggling, which we kind of knew. Now we're going to get the toggling of the flowers done, and then we should be done. Okay, and for those of you that are a little bit behind, here's the complete code so far. And we're going to talk about how to make the flowers toggle right now. Well, down here, I have ring counter. So now I want to do a little bit of kind of fun stuff with the flower. I'm going to say if ring counter mod 2 equals 0. So that means I'm on an even row. Then I'm going to say flower is equal to new picture, images slash, I don't know why I do it this way, but I do, flower1.jpg, else flower is equal to new picture, images slash, guess what, there's another flower, it's called flower2. Now both those flowers need to be scaled, so I'm reusing the same flower variable, but I'm either making it flower 1 or flower 2, so that should toggle. Both flowers need to be scaled. Scale 0.4, 0.4. And then we need to grab the flower grid again. So flower grid is equal to flower.getPixels to D, because the flower grid needs to change every time. Turns out both these images are the exact same size. If they weren't, you might want to go up here and reset flower rows and flower calls. See how I've said flower rows and flower calls to this and I've never changed them? That does happen to work right because these images are the same size. But if they weren't, you'd have to reset those as well. Okay, that should compile. And let's see if we can get some fun stuff going here with these flowers. Compile. Test collage. Takes a little while to do all the 2D array manipulations, and there we go. That is our beautiful garden. Oh, how wonderful. And I will leave the code up here. The complete code, again, is on Schoology as a completed version. So if you were having a tough time following along, you can either slow down the video and pause or you could go grab a look at the completed code. Hopefully kind of me walking you through that was a really good example of a complex 2D array algorithm using copy, using this for loop. I mean, there was some tricky stuff going on in there, but we managed to get all the math right. And now you can basically send a lovely picture of a garden to your friends. Thanks a lot, everybody. And there's one more video to go.